So this video is on our chapter 7, classwork number 2, logs and exponential practice. And for this, the reason I'm making this video, I want you guys to try the problems first on your own, and then on the ones that you're having trouble with, come watch the video for those particular questions and learn from that if you need help, okay? Again, I'd like for you guys to try the problems first. That way you know which ones you are having difficulty with, and then you can fast forward through this and find the ones that you need help with. Okay, so on this first one, we're graphing and we're going to identify asymptotes. So just a little reminder, this is an exponential. It's y equal a times b to the x minus h plus k. That is your general equation for this. Your a is going to be the number in front of this 2, because this 2 is actually our b. It is a thing that's being raised to the power. So the number in front of the 2 is a 1. So my a is going to be 1. My b is going to be 2. So the a is our start. I'm going to be starting 1 high. And then this being a 2, I'm timesing by 2, timesing by 2, timesing by 2. And this minus 5 here, that moves my graph down 5. This x plus 4 moves my graph to the left 4. So if you want to think of a critical point or a locator point, that locator point is going to be -4, -5. And you're going to have an asymptote down at y equal -5. Let me just clean that up. Y equal -5. So that's where your asymptote is going to go. So I'm going to come down here. I'm going to have an asymptote at y equal -5. And then this locator point, -4, -5, right here. This is where you're going to start your graph. That's where we're going to do your A, and then we're going to start timesing by 2, timesing by 2, timesing by 2. So again, I'm going to go to -4, -5, which is right here. That is where I'm going to go 1 above. So again, -4, -5 is right here. That's where I'm going to go 1 above because that's my start, my A. Okay, that is my A. Then I'm timesing by 2, timesing by 2. So if this is 1 high, next is going to be 2 high. As I go over 1 more, double that, 4. Double that, 8. Double 8, 16. So 9, 10, 11, 12, 13, 14, 15, 16. And then I'm going to connect this. And there's my exponential graph. Now the one next to it is an inverse of an exponential. It's not this inverse, but it's an inverse of an exponential. This is a logarithm. So these ones have horizontal asymptotes. These ones have vertical asymptotes. Okay. So for this one, if I am trying to think about how this graph has been moved, this has been moved 4 to the right and up 6. So 4, 6 would be like a locator point. Now again, you have a vertical asymptote. Your vertical asymptote is going to be at x equal 4. So I'm going to come to x equal 4, and I'm going to draw my vertical asymptote. And then I am going to come to this 4, 6, and this is where I'm going to start doing my graph. And my graph, I'm graphing log base 3. So kind of the values I want to think about: log base 3 of 1, log base 3 of 3, log base 3 of 9, and that's probably more than I can fit on this graph, okay? So again, I have moved 4 this direction and now up 6. So I'm going to be right here, 4, 6. And then this is where I'm going to go out. 1 for log base 3 of 1, 3 for log base 3 of 3, and so on. So as I am here and I go out 1, log base 3 of 1, is 0. So at that height of 6, I went out 1, but my answer was 0. Now when I do log base 3 of 3, so I go 1, 2, 3. Log base 3 of 3 is 1, so I'm going to go up 1. So again, I went 1, 2, 3, and log base 3 of 3 is 1, so I went up 1. My next one would be 9. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And log base 3 of 9 is 2. So it's going to be up here, kind of where my G is. And let me do it in a different color. It's going to come like this. And that's your graph. Okay. So again, vertical asymptote, x equal 4. I'm going to go to 4, 6, 4, 6, and this is where I'm going to go out 1 and 3 and 9 and 27, because those are all nice multiples, or sorry, 3 to powers. Okay, now this one is another log. The difference with this is it has a negative in front. So what that means is when I do my log base 5, I need to then take my answer and times it by the negative in front. Okay. So first off, my locator point would be 2, -7. This is moving to the right 2. This is going to be moving down 7. I am going to have a vertical asymptote at x equal 2. So let me draw that in. Okay, again, that's x equal 2. And then I'm going to be doing log base 5s. So I'm going to be thinking of log base 5 of 1 and log base 5 of 5 and log base 5 of 25, which isn't going to fit on my graph, but that's how we would be thinking about it. So again, I'm going to come to this 2, -7, 2, -7, so right down here. And this is where I'm going to go out 1. Log base 5 of 1 is 0. And I'm timesing it by a negative, but 0 times a negative is still 0. I'm going to go out 1, 2, 3, 4, 5. Log base 5 of 5 is 1. Times it by a negative, I get a -1. Just double check my numbers. 1, 2, 3, 4, 5, -1. And then I would go out 25, okay, which isn't going to fit on my graph. And log base 5 of 25 is 2. Times it by a -1, I go down -2. So this graph is going to look like this. Oops, let me move it a little bit. Try one more time. Okay. And that is our logarithm. Okay. So again, the negative is going to make every value that I'm going times it by a negative. So instead of going up, I'm going to be going down. This is moved to the right 2. My graph is also moved down 7. So I start at 2, -7. I go out 1. Log base 5 of 1 is, log base 5 of 1 is 0. Times it by a negative, still 0. I go out 1, 2, 3, 4, 5. Log base 5 of 5 is 1. Times it by a negative, -1, and so forth. Okay. On these ones, we're doing a basic exponential graph. Let me just get rid of this. We're doing a basic exponential graph where we don't have an x minus h or a plus k. We just have a number in front. Okay, now this right here is always going to be 0, your a when it's in this type of a form, when we have not moved it left or right or up or down. So this means my a is 2. Okay, so this is kind of a nice one. Okay, when they give you the y-intercept and they want it in this form, where it's not moved up or down or left or right, then your 0 is your a. So now I know I'm going to have y equal to b to the power x. I'm going to put in 1 comma 6. So I'm going to have 6 is equal to 2 times b to the power 1, because this is 1 comma 6. So this is going to be 6 is equal to 2b. I divide by 2 and I get b is equal to 3. So my equation is going to be y equal to times 3 to the power x. Done. Okay, so again, this one's nice when they gave you the 0, because that is going to be your a when it's in this form. Okay, not x minus h plus k. Okay, now this one here, this time they weren't so nice. They did not give me a 0, so I don't know my a. So what I'm going to do is I am going to do 2 equations. I'm going to put in a -2 and 8 into, again, y equal a times b to the power x. So I'm going to get 8 equals a times b to the -2nd. And then let me put in the other point. So I'm going to do -1 comma 2. So I'm going to get 2 is equal to a times b to the -1st. Now, we're going to have to solve the system. What you're going to want to do is to get one of these equations to be a equal. A is easier to get to by itself than b. B has an exponent, I have to do a little more work. I would always recommend doing the one that has the smallest exponent. Okay, so the smallest exponent happens to be this -2. Okay, so I'm going to rewrite this in terms of a. So I'm going to divide both sides by b to the -2nd. So I'm going to have 8 over b to the -2nd, okay, is equal to a. Now, b to the -2nd, b to the -2nd, I don't like that -2nd. If it's a negative exponent, you can move it up. So this ends up being 8b squared is equal to a. So I am going to put this here for a, okay? So again, this is going to go in place of that a. So I am now going to have 2 equals, and in place of a, 8b squared times b to the -1. 2 is equal to 8. And then here, when I have b to the second times b in the -1st, you add them. And so I get b to the 1st, or b. So I get 2 over 8 equals b, or 1/4 is equal to b. Now I want to find my a. So I'm going to put 1/4 in place of b here. Okay, so I'm going to go 8 times 1/4 squared equals a. Now 1/4 squared is 1/16. So this is going to be 8 over 16 equals a. So I get 1/2 is equal to a. So my equation is going to be y equal 1/2 times 1/4 to the power x. Okay. So y equals 1/2 times 1/4 to the power x. Let me write that in a different color. Y equal 1/2 times 1/4 to the power x. So these ones we are rewriting in exponential form. So remember, this base is always your base, and your log always equals your power. So whatever your log equals, that's going to be your power. So 4 to the 4th is equal to 256. That is your answer. Now this one here I'm going to do, since it's in the screen here, anytime you have no number for your base, this is going to be, so just log with no base is base 10. Okay, so this automatically is base 10. And we call that a common logarithm. Common log. That's what log without a base is. So again, this is what your log equals. That's your power. Your base, since you don't have one here, is base 10. So it's going to be 10 to the second equals 100. And this is what the log is on your calculator. So this log button right here is base 10. Okay. It's not any other base. Okay, so now let's take a look at these two. So on this one, again, what your log equals is your exponent. So this is going to be 2 to the 5th equals 32. Again, log equals your exponent. So this is going to be b to the x is equal to y. So on the next page, these ones we're evaluating. Okay, we're trying to figure out what these equal. So this is really saying 4 to what power gets us 64? 4 to what power gets us 64? Now, you might know what this is. 4 times 4 is 16. 16 times 4 is 64. X is going to be 3. So your answer is 3. Okay. Now, you didn't have to write it with an X. So if you can just do this in your head and you know that for log base 4 of 64 is equal to 3, that is your answer. 3. 3 is your answer. Okay, so this is saying 3 to what power? So again, I'm just going to write it like this. 3 to what power is equal to 1/3? So remember, if it's a fraction and it's been flipped, that means it's been raised to a negative. So x is going to be a -1. And again, when you're writing this, I put the x there just to kind of help us think about it. You don't need to write the x. If you can look at this, log base 3 of 1/3, and in your head you can go, hey, 3 to what power gets me 1/3? Oh, -1. That's fine. -1 is your answer. Okay, number 14. So on 14, again, we can think about this being x. We're trying to find it. 8 to the x equals 16. This one I'm going to have to do a little work on because 8 to no nice power gives me 16 because 8 to the first is 8. 8 to the second is 64. I'm already beyond 16. So I know it has to be 1 point something. So now I'm going to get these to be the same base. An 8 and a 16 can both be 2. This is going to be 2 to the 3rd raised to the power x. So that means 2 to the 3x because power to power would have multiplied. And 16 is 2 to the 4th. So I get 3x is equal to 4. Once the bases are the same, you just set the exponents equal to one another. And then you solve and you get 4/3. And that's your answer. That's what log base 8 of 16 equals. It equals 4/3. Okay, so these ones we're going to be using those properties from the other day. And we're going to be trying to write these as a single log. Okay, so let me start us off. Log base 4 of something. Okay, of something. Now, when two logs of the same base are adding, you can multiply these together. So this is going to be a 12 times a 2. And then when it's a minus, it is dividing. Okay, let me just clean this up. So log base 4 of 24 over 3. Okay, So this is going to be log base 4 of 8. And that's what it would be as a single log. Okay, now if they wanted you to evaluate this, then you would be going 4 to what power gets us 8? And kind of like that problem I was doing before, I can get both of these to be base 2. So this would be 2 squared is 4 raised to the power x, so 2 to the 2x equals 2 to the third, which is 8. So I get 2x is equal to 3, x is equal to 3 halves. That's what it equals. Okay, this is what it looks like as a single logarithm. Okay, on the next one, when you have a number in front of a log, that becomes the exponent. So this is really going to be log of 2 to the 5th minus log of 2 to the 2nd. Whoops, forgot my 2. Minus log of 2 to the 2nd. So what I'm going to get is log of 2 to the 5th over 2 to the 2nd. So that's going to be log of 2 to the 3rd. And 2 to the 3rd is 8. Now, if you wanted to, at this point, you could have rewritten 2 to the 5th. Let me kind of clean that up. Let me make my G a little smaller. Okay, so this 2 to the 5th is really a 32 over 4, and 32 over 4 is 8. Or since these are both 2 to powers, I can subtract the powers and get 2 to the 3rd. But your final answer is going to be log of 8. Okay, again, we're going to write this as a single logarithm. So this is going to be log of something. Now, this 2 is going to become the exponent, so that's going to be an x squared, times on top because of that plus. This 3 is going to be the exponent of this, so y to the 3rd, over, and this is going to be raised to the power 4, and since it's a minus, it's division, so z to the 4th, and that's your answer. Log of x squared y cubed over z to the 4th. Now these ones are going the opposite direction. We're expanding these. So I'm going to be having multiple logs here. And all these logs are going to be base 2. So I have a product. That means I'm going to have 2 logs separated by a plus. And then this division means I'm going to have a log with a minus. So this is going to be log base 2 of x plus log base 2 of y minus log base 2 of z, and that's your answer. So I'm going to have a log for the 6, a log for the x, and a log for the y. So this is going to be log 6 plus, because these are all multiplying. And then when I take log of x to the 3rd, the 3 is going to come in front. So I'm going to get 3 log of x plus log of y. And that's your answer. Now on the next one, a couple things to kind of pay attention to. This right here is really a y to the 1/2. And this right here is really a z to the 2/3. Your root is always the denominator, okay? The power is always your numerator. So this is being raised to the 1/2. This is being raised to the 2/3. Okay, so now we're going to write this as a single logarithm. I'm sorry, as separate logarithms, one for the x, one for the y, one for the z. So I'm going to have 2 log of x because the square is going to come in front. And then this is really a 1/2. So this is going to be 1/2 log of y minus, and then 2/3 log of z. And that's your answer. And that's it for this worksheet. So again, hopefully you tried these problems and then came and took a look at the ones that you need help with. And I hope this video helps you guys out.